All right. So today we are going to learn about light. So what are the objectives that you actually need to know? So this whole topic, right, for Sec 1, there are certain things that you need not know. I will highlight to you later on. I think some questions in the worksheet you find difficulty answering as well, right? Yeah, because some are really higher level and you need not know this, because if you want to know everything about light, it takes quite a while to explore, okay, and understand fully the topic. But at Sec 1 level, you need not know so much yet. Okay, I have double checked because there are certain questions that I brought back, and then I started to do a little bit of, research, finding out what is done in secondary school again. Okay, just double confirm, okay, whether like these few years there is any change in what they are teaching. So I have confirmed with some teachers already, okay, to make sure different schools are not doing different things. And also the standard required, all right, for your O levels, but it's still a long way from now. Okay, so you need to know about reflection. Yeah, so there are reflection happens all the time. It's just whether it's happening on a smooth surface or a rough surface. We're going to explore a little bit later. Okay, then characteristics of the image formed by a plane mirror. All right, and then we also talk about concave mirror and convex mirror. Yep, describe the effects and uses of reflecting surfaces. Okay, effects and consequences of refraction. Then describe dispersion of white light by a prism. Explain how we see color of objects in white light and colored light. Then compare speed of sound, speed of light, and common moving objects. Okay, but most of the time they focus on the top 1, 2, 3, 4, 5, and 6. Okay, top 6. Yeah, comparing the speed of light, sound, you just need to know. Okay, that speed of light is the fastest. So how do you represent light? You use straight lines, okay, to represent one ray, one straight line for one ray. Yeah, so it's usually the path taken by light from the source. Okay, this example is the candle, okay, to the target. So target means who is actually seeing this light. So a beam of light will then be a stream of light rays. So it's represented by many straight lines. Note that they are actually parallel. Okay, they are traveling in straight lines in parallel. Light travels at this speed. Okay, so that means it's about 300,000 kilometers every second. So that's why in thunderstorm, right, you are going to see flashes. Okay, see flashes of lightning before you hear the thunder. Okay, so most of the time we see the flashes already, right? And what do? You see some young children or some ladies like myself, we will cover our ears, okay? Because we are worried that, it's going to be very, very loud, okay, and we will get a jump scare. Okay, so speed of light is faster than speed of sound. So how do we see light? It's due to reflection of light. Okay, so it involves two rays. Note that it involves two rays. One is the incident ray, that is the incoming ray. Yeah, and then it hits the surface, right? And it gets reflected. So the reflected one, we call it the reflected ray. This is the example. So this is the source of light. Okay, and then the light comes in. We call this the incident ray. It hits the surface and gets reflected. All right. When light strikes a smooth surface, such as a mirror, it's going to lead to a reflection called regular reflection. Sometimes you hear a video saying specular reflection. Books will say this as well. Certain books, they are the same thing. It's just regular reflection. So you are going to see that the parallel rays, right, that comes in, we call them the incident rays. They're all going to be reflected, okay, in parallel as well. So these are the reflected rays. So for smooth surfaces, we get regular reflection. But, okay, For surfaces that are very rough, such as clothing and paper, okay, it's going to lead to a type of reflection called diffused reflection. Okay, this diagram, I'm not very satisfied. I'll show you a better one later. Okay, so the law of reflection holds in diffuse reflection. The rays of light strike the surface, but they are scattered. They are scattered in many different directions. So the image is either blur or you can't see any image. All right, so I show you this better one. Okay, so this is how it looks like. So incident ray comes in. So you have the incident ray coming in here, right? Hits the surface, it gets reflected. Because of the uneven surface, okay, every ray that comes in, even though they come in parallel, right? When they hit the surface, they are going to get reflected. And they are reflected according to the angle they are at. So let me show you something. You need to learn how to draw these. Find my ruler first. Okay, so let's say, imagine this is my surface. Okay, and then I need to draw the light ray that comes in, right? So let's say there's a light ray, just one light ray that comes in. With the arrow, very important because they are going to mark you according to where the light ray comes in, okay, and then how it's being reflected. So the ray that comes in, we call it the incident ray. Okay, then how does it get reflected? To be accurate, you need to draw this called the normal. We usually represent this with a dotted line or dashed line. Okay, so this is the normal. We will label it this way. Don't say normal line, it's normal. Okay, so the reflected ray will then be, okay, I try to be as accurate as possible. This is the reflected ray. So this angle, okay, between the ray and the normal is called the angle of incidence. We represent it by I. This one over here is the angle of IO. What's happening? Angle of reflection. So these two angles must be the same. Can y'all take a picture? Or you can wait for me to send you the slides, the notes. Okay. So I represents angle of incidence. Okay. R is actually the angle of reflection. And you take note for every single ray here. All right. So there will be a normal for each of them. For example, if I take this particular ray, okay, there should be a normal like this. Okay, something like that. So over here, then you have the normal here. You understand? So this one, the normal is slanted. It really depends on which part of the surface it is touching. Clear? So because every ray is going to have its normal, and then the reflected ray will move accordingly based on the angles of the incidence and the angle of reflection. Any question here? No. So you need to learn how to draw this. Yeah. Next. So when you have, let's say, in daily life, we see a lot of example. Not too sure whether you notice this, but I always notice something like that, even in Singapore. Okay, so when the surface is very smooth, okay, so you look at the water, it's very calm. The water is not moving. You see that the surface is very still, very calm. You get a reflection that is regular, and you can exactly see the image, okay, very clearly. So this is what you can see. However, if let's say the water is not calm, it's not still. For example, this one. Can you see any image there? Any reflection there? You can't see, right? So for diffuse reflection, most of the time you either don't see an image or you see an image that is blur. Okay? They say the water is rough is because the water is moving. You can see the waves there. So image form is blur or you can't even see it at all. All right with this? So far, okay? Thumbs up if you're okay. Okay, good. Good. Right. So let's look at the image formed by the plane mirror. So we look at the mirror every day and we see ourselves in it. How many of you look at yourself in the mirror many times a day? Yeah, Aaron, notice my hand is also up. Yeah, because I look at myself all the time in the mirror just to make sure, my hair is neat. Okay. After eating, I make sure that there are no, food stuck between my teeth, etc. This is what I do. Okay, because I have to face people every day and talk to them every day, right? Yeah, I want to look presentable. Okay, as you grow older, you might also find that you'll be looking into the mirror many times a day. Okay, so how do we see ourselves in the mirror? We are talking about a standard plane mirror. Okay, so the image is going to be upright. We don't see ourselves upside down. Okay, we are the same size. I know nowadays we have mirrors that cause people to look slimmer, right? So models, celebrities, they like to buy this kind of mirror. Why? Because they feel good looking at themselves in a mirror. Okay, this is true. So there are mirrors that cause people to look slimmer. Yeah. But it should be the same size when we are talking about the standard mirror. In science, when you are answering your question, we are basing it on the standard plane mirror. Laterally inverted, okay, left will appear to be right, right will appear to be left, right? Same distance behind the mirror as the object is in front. Okay, and then it's virtual, it's not real, so it's virtual. You need to know these 5 points. Yeah, so usually they ask you for at least 2 or 3, okay, but there are times when they actually write down maybe 3 of them, they will ask you to fill out another 2. So you better know all of this. So take a look at this. Have you seen this kind of mirror in a car park? Maybe? Yeah? Yes. So what is this kind of mirror? Actually, they have a name. They are called the convex mirror. When you look at convex mirror, you actually see a very big area. Okay, even though the image looks smaller, right? Kind of, but you see actually a bigger area. Then, if you go to the dentist, yeah, the dentist will use this special mirror, okay? It's called a concave mirror. It will allow your teeth to look a lot bigger so that the dentist can see clearly what is the problem there or identify whether there's any problem with your teeth or your gums. Yep, so this is enlarged. Okay. So this one is an interesting example. Look at the 3 images. Will you be able to tell me which one is actually concave, which one is actually convex? Did you want to try?
The first one is convex. The second one is concave.
First one is convex.
Yeah.
You think that this is convex?
Yeah.
And then this is concave. What about the third one?
Just a
plain mirror.
Yeah.
You think that this is a plain mirror? Okay, let me see.